Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and this is a chemistry lecture and the topic is wave mechanics. In this wave mechanics lecture, this is lecture number 2. I will explain you again Heisenberg's uncertainty principle. In previous lecture, I explained you what is the structure of atom and Bohr's model and how Broglie was not in favor of Bohr's model. Even Heisenberg is also not in favor of Bohr's model. According to Bohr's model, every atom has a nucleus in which all protons are found. Electron revolves around nucleus at a definite distance. So we know exact mass of electron, we know velocity of electron, we know radius of atom. So if we know MVR, we know angular momentum of electron also, momentum of electron and position of electron. So in Bohr's model, position of electron as well as momentum of electron and angular momentum of electron is known. Well, Heisenberg was not in favor of this measurement. Why? Because he realized that an electron is a microscopic particle, and when microscopic particle revolves or move, then it is very difficult to predict the exact location as well as momentum of electrons simultaneously. Anyway, let us see how Heisenberg tried to explain it. So this is let us take microscope. This is a microscope and we have to put atom under the microscope. So this is atom under the microscope. This is a nucleus, and electron is continuously revolving around this nucleus in this circular path. Now we would like to know the exact location of electron. So we have to focus this electron with light. So the light which is used in this microscope is gamma rays. So we can use gamma radiations to find out the location or momentum of electron. Okay, and here this is the center of microscope. Well, we can draw a line from center. Okay, so now we can say that this is O, this point is M, and the position of electron say X, and this angle is alpha. Okay, so we can say that position of electron is X, and as this angle is alpha, so we can say that sine alpha is equal to OM upon MX. Okay, so if this is a position of electron X, obviously the electron is continuously revolving around nucleus. So the moment we measure the position, this electron may slightly move from its position, and therefore there will be small error in measurement. Okay, so if position of electron is X, then change in position of electron because of its movement, and it is also known as error. For change we put delta sign, so this we write delta x. So delta x is a change in position of electron, or we can say it is an error in measurement of position of electron. Now what is the relation between delta x and lambda of or wavelength of electron and sine alpha? So we can say that delta x is proportional to lambda upon sine alpha. Okay, and that means if wavelength of electron is increasing, error of electron increase, or light increasing, then error of measurement of position increases. And if sine alpha decreases, then error will be increasing. Okay, because it is inversely proportional. So now according to Broglie's theory, we have Broglie's equation, lambda is equal to h upon mv, or lambda is equal to h upon p, momentum, because p is equal to h upon, as p is equal to h upon lambda, we can say like this. And now Einstein's equation, E is equal to hc upon lambda. Okay, so for photon of gamma rays, because we are using gamma rays, why we are using gamma rays to find out the location of electron, now you will understand. Because gamma rays is having minimum wavelength and maximum energy. Okay, so for gamma rays, lambda will be minimum, but momentum and energy of gamma rays will be very high. So if gamma rays, we are using gamma rays for observation of electron locations, that means for gamma rays P will be very high, and therefore change in momentum of electron, again it is error in measurement of momentum, which may be delta P, and delta P is proportional to h upon lambda into sine alpha. Now when we see delta x and delta P, we will see that both are inversely proportional to each other. Why? Because if delta x is high, that means error in measurement of position is very high, then delta P will be very low. Why? Because the condition is opposite. Okay, that means for accurate measurement of position of electron x, delta x should be very small. And to keep delta x very small, the light used in machine must have minimum wavelength, and sine alpha should be large. To increase sine alpha, we need huge microscope. So this is a condition for measurement, accurate measurement of x. And for accurate measurement of P, delta P should be very small. And to decrease delta P, wavelength should be large. That means we need microwave or radar wave or maybe radio waves to measure momentum. And sin alpha should be very small. And for that, we need very small microscope. So thus, with the one instrument, either you measure X or you measure P. But you can't measure both with the same microscope. Why? Because you have to take either small microscope or a large microscope. You have to use either a light having wavelength minimum or maximum, and both the conditions are reverse or opposite, and therefore either you measure X or P. And if X and P are measured simultaneously, then there will be error in both. So delta X times delta P will be proportional to lambda upon sine alpha into H upon lambda into sine alpha. So we can say that delta X times delta P proportional to H. H is a constant, and that is why if you want to put equal sign, you need another constant, and Heisenberg calculatively found that delta X into delta P is either greater than or equal to H upon 4 pi. And this is known as Heisenberg's uncertainty principle, or delta X into m delta V is greater than or equal to H upon 4 pi. So if you put delta X on left side and delta V on right side, we can say that delta X proportional to 1 upon delta V. So either you measure X or V, but you can't measure both simultaneously. So this way, the Heisenberg's principle is, it is not possible to measure simultaneously the position and velocity of microparticles like electron, proton, with accuracy. So according to Heisenberg, either you measure position of electron or you measure velocity of electron. And if you try to measure both simultaneously, you will get error in measurement of both. Okay, so that's what Heisenberg said about atom. So according to Heisenberg, atom is uncertain sphere. That's it in this lecture. Thank you so much.